Because of its core nature and novel approach, proof of justice enables the implementation of several interesting and helpful mechanisms, some of which include dynamic parameters, dedicated nodes, and specialized subnetworks. A parameter is a value that is part of the system. The parameter's value may be altered based on certain events or criteria. For example, a poll is started to propose an update to the value, and if 2/3 of the entities in the network agree to do it, then the value would be updated. The voting process may be initiated by any entity in the network that has the authority and reliability to do so, for example by having a global reliability score above a determined threshold. The voting mechanism can be similar to the several ones proposed in previous videos. In one or more implementations, only the entities with the top percent of the highest global reliability score can vote in updating a parameter. In some implementations, in order to vote, entities must have completed a special challenge within a determined number of previous blocks to show that they are eligible to vote. The degree of change to a given parameter can also affect how many entities need to vote for the change to take effect, or which entities can vote. In one or more implementations, some of the parameters are static, meaning they cannot be changed with a voting mechanism. Some implementations may choose to implement a system using dedicated nodes, which are physical devices that act on behalf of an entity in the network to generate blocks or perform other actions. Depending on the implementation, a dedicated node can either be able to perform all roles, a handful of them, or a single one. For example, one dedicated node could be used to solely generate and enforce blocks, while another might store data on a dedicated hard drive in addition to generating and enforcing blocks. While optional in some implementations, others may choose to make dedicated nodes a requirement to participate in the network. A dedicated node can be particularly useful for several things. Firstly, if the main node, such as a phone or computer, goes offline, the dedicated node could operate while the main node is offline, and once the main node comes back online, it would simply synchronize itself with the dedicated node, which would allow users to maximize their rewards by always participating in the system. Secondly, having several entities in the system using similar node computing hardware can help to level the playing field and increase fairness in the network. Thirdly, having a physical device that is always online and connected to the network provides a more reliable experience for users. Lastly, it allows the creator of the proof of justice-based system to have an additional great income stream. Since a node in proof of justice does not require a large quantity of computing power to operate, dedicated nodes can be manufactured at a minimum cost, enabling higher accessibility to users and potentially high profit margins. Proof of justice-based systems can also implement a mechanism where the network is divided into multiple subnetworks, each being associated with entities with a given role. For example, there could be a subnetwork for all generators and another subnetwork for all enforcers, making it much more efficient to perform the entity selection process described in a previous video. A subnetwork's mechanism has the potential to greatly improve the overall speed of a proof of justice-based system, given that, in the case of decentralized systems, the networking algorithm can be a major throttle. BB Inventions, high-tech research for curious minds.